So does A over R times the quantity R squared plus S squared plus C squared equal A times R plus B times S plus T times C? Good question. We can do a little simplifying of this first. Usually you want to try and multiply these things out if they give it to you in some form, because basically it's not always true, but a good general rule is they're going to give you something in the form you don't need. Otherwise, the questions are easier. So a good assumption is that you're going to have to multiply things out or factor them if they don't give them to you in that form. So we multiply both sides by r to get rid of this fraction here. We end up with A times R squared plus S squared plus C squared equals AR squared plus B or RBS, doesn't really matter what order those go in, plus RTC, which may not look like it helps, but then we have AR squared plus AS squared plus AC squared equals that same thing. You can see that we're going to be able to get rid of a term here, which is why we were doing that. There's an AR squared on both sides of the equation. Now we just have AS squared plus AC squared equals RBS plus RTS. RTC. Sorry about that. Okay. So we could factor out the A again, but just based on looking at the answer choices, there's nothing that suggests that that's going to be any more useful. But reducing these expressions into two binomials does make it easier. So statement 1, if we cross multiply, we get RT equals AC. So the reason this helps is that we can substitute an AC wherever we see RT. So we could say that this second term here is going to be AC times AC times C. So it's actually, we can tell that this is going to be AC squared. But we don't have anything to do with this first term, so statement 1 is not going to be sufficient. It's not going to be A or D. Statement 2, when we cross multiply, we get AS equals RB, which means we can substitute an AS in for RB, but we have to ignore that we could do this. So this ends up being AS squared. But again, we don't have the other term in the binomial, so that's insufficient. We can cross off B. But we can see how this is leading towards sufficiency. If we can substitute AS for RB and AC for RT, we can end up with an equation AS squared plus AC squared equals AS squared plus AC squared, which is true. That's what the question was asking. Does the one side equal the other? So the two statements together are sufficient to answer the question in the affirmative.